Okay. We have to classify each of the following as either a pure substance, a homogeneous mixture, or C, a heterogeneous mixture. Okay? And number 11, water that exhibits the Tyndall effect.
C.
Yeah, that's a heterogeneous mixture. Okay? 12, any metal alloy. Is B, a homogeneous mixture. Absolutely. 13, smoke.
C.
Yeah, a heterogeneous mixture. Again, C. 14, a pre-1970 copper penny. It's a pure substance. A, yes. 15, seawater. Yeah, a C, a heterogeneous mixture. And the reason you can, well, how could you tell that if you went out on the ocean? The Tyndall effect, exactly. You see the light beams hitting you ever seen the light beams hitting the ocean? And you see the light traveling through the water? That's due to the Tyndall effect, which is the scattering of light by the undissolved particles. Okay, number 16, 1 ounce of gold.
Pure substance.
Yes. That's a pure substance. 17, and this is probably the ambiguous one. There won't be one like this on the actual test. And that is milk. It's C. It's a heterogeneous mixture. It's not at all obvious. Even if it says homogenized milk, if you look at it closely, it's actually suspended. It's a suspension. Okay, and number 18, a large crystal of sodium chloride.
B.
It's pure substance. A. Yeah. That's a pure substance. You know, the fact that it was large had nothing to do with it. It was a crystal of sodium chloride. Armed with just that information, it would be a pure substance. Okay? Any questions about that? That wraps that portion. And now, last but not least, oh, you had a question?
Yeah, can you explain some of the different features that you tell between them again? Between the homo and the hetero?
A homogeneous mixture is something where, like a homogeneous mixture would be like a solution where everything is uniformly distributed throughout the same phase. So there is no there's no irregularity. In other words, like it doesn't have to be a liquid solution, but like if I dissolved sugar in water and I shine my laser through that sugar water solution, I don't see the light traveling through it because it's all dissolved. Now those sugar molecules are uniformly distributed throughout the water host. And they're in the same basic phase. They're in the liquid. They're in that phase. And so that is distinct. That is a homogeneous solution. That would be a better word for it, as a solution. A heterogeneous mixture would be one where, like we were saying, or let me give you another example of a homogeneous first. It doesn't have to be in liquid. It could be a solid, like a metal alloy, brass, which is a solution of zinc in copper. It's an alloy, and all metal alloys are solutions of metals within metals. The host metal being the one that's there in the the greatest amount. But they're uniformly distributed. In other words, they're throughout. They're in the solid phase, but they're not like little domains, little chunks of zinc and little chunks of copper, which are isolated. They're distributed uniformly throughout. That's a key feature. It has to be uniformly distributed throughout the same phase. Yes. Did you have a question about that?
I was reading sometimes there's metals that have crystal dominant that's they have a pattern that's got with black and then it peels off the way it's uniform.
Yeah. I don't know. That would be okay. that wouldn't be that wouldn't be uniform on the scale we're talking about. Because the dye molecules, it may be all plastic. Let's say it's all plastic, it's all the same polymer, but I have different dye molecules in different regions. So there's a little domain here where there's a speck of purple, for example. And here it's contained in a pink background, you know, and then I've got another one over here, you know. Okay, that is not uniform. And so that would not be a true homogeneous, although it's pretty close.
Question, would that apply to
Granite
granite countertops?
countertops? Yeah, because you can see it visibly.
Yeah.
There's different domains, it's not uniformly distributed throughout. Okay, and so those are good examples, I like that. Those are examples of a heterogeneous mixture, yes.
So what would differentiate the NaCl between the brass would be that there's no interaction between the brass?
Well, no, the brass was a mixture of copper and zinc. Okay. The sodium chloride is an ionic compound. That's the ionic formula. It's just sodium chloride, sodium chloride, sodium chloride. It's a pure substance, pure sodium chloride. Whereas the brass was copper and zinc. And there's not they're not necessarily in a formula unit like a ratio with an integer, a whole number of integers, multiples. It could be, you know, it could be a variable amount of zinc, but it's going to be uniformly distributed throughout. So it's a homogeneous solution. It's a solid solution. Okay, air we're breathing is a. If I shine my laser through the air, see if I got my laser. No, that's not my laser. Where's my? Oh, here's my laser. See if it still works. Yeah. Do you see the beam traveling?
No.
Okay. That means that this is a homogeneous mixture of nitrogen and oxygen. Now, if I wanted, for the sake of science, if I lit a cigarette here, not because I wanted to smoke, but because I wanted to demonstrate for you all in a self-sacrificing way. The Tyndall effect. I could light, if I lit a cigarette and I blew the smoke out here, what would you see? You'd see the light traveling through it, right? And that's because the light's being scattered off the particles. It's not a homogeneous mixture anymore. These particles are suspended. It's an aerosol suspension. Doesn't have to be suspended in a solution, but that would be the fact that you could see the light being traveling through it. Would it be an indication that it is indeed a heterogeneous mixture? So if it, or dust would do it just as well. The Tyndall effect is the scattering of light off of the non-dissolved or particles. Okay, same thing in the water and the salt water.
So if homo is where it's uniform distributed?
It's
throughout,
uniformly distributed. That is a requirement for a homogeneous mixture.
so then how would you say hetero? It's not.
Heterogeneous is not uniformly distributed. The post 1970 penny. If I don't have any pennies on me, let me see if I got one on me and what year it is. Okay, this penny right here. Well, let's take this one. Look shinier. This is 2011. Okay, this is just a piece of zinc that's clad in copper with a copper jacket around it. This is a heterogeneous mixture. There may be pure copper in the coating and pure zinc in the middle in the core, and it is. It's not. They haven't alloyed it. If it was alloyed, it'd look a lot golder. It'd be brass. But this is a heterogeneous mixture. Okay.
Nichrome is a metal alloy too.
What?
Nichrome is a metal alloy or is it?
Nichrome? Yeah, nickel and chromium,
Oh, okay.
and a few other things. Yeah. But if it's an alloy, it's a it's a metal solution, solid solution. It's uniformly distributed throughout. Okay? Okay. Whereas that's not to be the same thing as if I electroplated something on a surface of one metal. That's a different thing. That is actually heterogeneous. Okay? Have we beat this question to death?
Yeah.
So we can get to the last group of questions? Okay, stop